All right, section 4.1, we're going to talk about the chain rule. Chapter 4 is called more derivatives. So all of chapter 4, we're going to be learning more rules of derivatives. In other words, how to take the derivatives of different families of functions and types of functions. So today, I'm going to start off with a problem here that I don't think you know how to solve at this point with the rules that we learned from chapter 3. And that is finding the derivative of y equals x squared minus 1 to the fourth power. I don't think you know how to do this because it's not strictly a power rule. The power rule is if you have any monomial that is x to an integer or a rational number, then the power rule applies, and it's multiplied by the exponent and subtract 1 from the exponent. That's the rule, right? But this does not fit that. This is not a monomial, one variable to a power, or to an exponent. It is a function inside of another function. It's x squared minus 1 inside of something to the fourth power. Maybe it's x to the fourth power, and you've placed x squared minus 1 inside of it. In other words, it's a composition of functions. And so to take the derivative of composition of functions, we need a different rule. We need the chain rule. I'm not going to get into really why the chain rule is what it is. The book has a decent explanation, I think, and the reason why is not really that important to us going forward. If I thought that it was going to be useful, then I'd certainly get into it, but it just really isn't. So we are just going to learn the rule. So for a composition of functions, or composite function, I guess that would be shorter to write, composite function, f of g of x. Remember, I think it's helpful to write it like this, f of g of x, like that. Here's the rule. The derivative of f of g is equal to the derivative of the outside function, leaving the inside alone, so f prime of f, leaving g of x inside, times the derivative of the inside function. Okay? So what you really want to focus on is outside and inside. What is the outside function? What is the inside function? Okay. So just to summarize, what I'll be saying a lot throughout the examples is derivative of the outside, leave the inside alone, times the derivative of the inside. Very similar with the product rule. I said the same thing over and over. It was the first derivative of the second plus the second derivative of the first. With this one, it's over and over. It's going to be derivative of the outside, leave the inside alone, times the derivative of the inside. Okay. So I think the best thing to do is just to start off with, just to go through some examples, just so you can get sort of familiar with how the rule works. In fact, let's start off with something that's very, very, very simple. Y equals x to the fifth. With the rules on all of these, take the derivative. Okay. So I'm going to claim that this problem that you know how to do, it's 5x to the fourth, right, is actually an example of the chain rule. In fact, you know what? No, let's pause that because I think that could possibly confuse you if I start with that. Let's start with the problem that we were given up here. Okay, so we'll come back to this, I promise. So same instructions, take the derivative. X squared minus 1 to the fourth. All right. So the first thing that you want to do is identify what is the inside function, what is the outside function. We already sort of talked about it. This x squared minus 1, that's your inside part. Okay. So in the context of this up here, that's your g of x. So what's the derivative then? Well, what you'll do is you'll take the derivative of the outside. Now, you can imagine the outside being just a thing to the fourth power. Well, if it was just x to the fourth, you'd put the 4 out in front and subtract 1 from the exponent. So it will look like this. 4. Leave the inside alone. Subtract 1 from the exponent. You get 3. Times by the derivative of the inside. So here's the inside. What's the derivative of that? Well, that would be 2x minus 0. So just 2x. Okay. And so there's your derivative. All right. And again, if you want, I'm not going to do this every time, but you can kind of list out like what is my f of x and what is my g of x. So my f of x in this case would be x to the fourth. My g of x would be x squared minus 1 if I'm following this notation up here. Okay, you don't need to do that every time, but you can think of it like that. So let's go back to this problem here, this y equals x to the fifth. I'm going to claim this is a chain rule problem and that the inside function is just y equals x. In other words, my f of x is x to the fifth, and my g of x is equal to x. Let's see if that works. So then dy dx would be 5 out in front, leave the inside alone, subtract 1 from the power, times by the derivative of the inside. Well, the inside is x, and so when you derive that, you're just timesing by 1. So we get 5x to the fourth, which is what we got with the power rule. Okay, so I think it works. I think it's a rule that scales to even simpler problems. Let's do another one. Let's take and try this one. Now again, you should try this problem, see how you do, and then play the video through. Or try the problem, play the video through, and see how you do. So f of x equals cosine of x squared plus 1. First of all, pretty clearly a composition of functions. Probably wouldn't know how to do this without the chain rule. The inside function is going to be x squared plus 1. So this is our inside function right here. The outside function is cosine. So when we take the derivative, we'll do this. F prime of x is equal to, the derivative of the outside is cosine, so that'll give us negative sine. Leave the inside alone. So in fact, I'll write that in blue for your learning convenience. This is the inside function right here. Okay, leave it alone. Times by the derivative of the inside. The derivative of x squared plus 1 is just 2x. Okay, so you can see it sort of makes a chain. Outside, derivative of the outside, inside, derivative of the inside. Okay, and then you might clean that up by kicking the 2x out in front. But I'm not worried about simplification at this point. Let's do another one. As you can imagine, with composition of functions, there are many variations of problems that you can now take the derivative of, because you're no longer limited to just a few types of functions. Now you can compose all of those different types and take the derivative of them. We already did one like that. I think we should do one like this. So here's y equals x cubed plus 2x squared minus x to the negative 2, all raised to the negative 7. Okay. So now we're going to take the derivative, again trying to identify the inside and the outside function. How about a different color for your learning convenience? The inside function here is x cubed plus 2x squared minus x to the negative 2. That's our inside part. The outside is a thing to negative 7. Okay. So we'll start by kicking the negative 7 out in front, deriving the outside, that is, leaving the inside alone. X cubed plus 2x squared minus x to the negative 2. Subtract 1 from the power, that's negative 8. Times by the derivative of the inside. So now we're going to derive this, I guess it's not a polynomial, but anyway, this expression on the inside. So the derivative of that will be 3x squared, 4x, plus, so timesing by negative 2 will give me plus 2x to the negative 3, and that's it. There's my derivative. There's no need to simplify that. Really, if you want to, then I guess you can, but there's not a lot to do there, besides maybe distribute the negative 7. Okay, I want to do one more for this part of the lesson, and then part 2 we'll talk about a couple of different types of examples, so or a couple of other types of applications of the chain rule. So last example for this video. Here's our function. Again, we're going to take the derivative, so I get tangent of 5 minus sine of 2t. Okay. So again, focus on what's your inside function and your outside function. 5 minus sine of 2t is my outside function. When I derive the outside, 5 minus sine t is my inside function. When I derive the outside function, tangent, this is what I get. Secant squared. Leave the inside alone. 5 minus sine 2t. okay, times by the derivative of the inside. Now, be careful here. The derivative of the inside function here is actually a composition of functions. So if I were to give you this, just the sine of 2t, and I said, okay, sir or madam, derive sine of 2t, you would be like, oh, well, shoot, that's a composition of functions because it's sine with a 2t function inside of it. So inside function would be 2t, outside would be sine. So we're going to have to be careful here. When I derive 5 minus sine of 2t, I get derivative of 5 is 0. Derivative of negative sine of 2t. Well, the derivative of sine is cosine. So what I'll have is negative cosine of 2t, leave the inside alone. But now I have to times by the derivative of the inside of this function here. So I need to multiply by the derivative of 2t. That's just 2. Okay, so there's my final answer, and that looks hideous. I'm going to write it all in black here. So f prime of x would be secant squared 5 minus sine 2t. I'll take this negative out in front of everything, I guess. And then I've got, and probably that 2 as well. So negative 2 secant squared cosine of 2t times 2. Nope, I already did the 2. So we're good. So yeah, I don't need times by anything. All right, so there's the final answer on that one. So that is a chain rule problem where there's a composition of 3 functions. All right, so in the next video, we'll look at an application of the chain rule. But otherwise, that's the basics of how it works. Okay, I actually kind of lied. This is something that comes up. I just thought of this off the cuff here. That comes up every year that is worth putting in the video. If I want to take the derivative of this is what it looks like. When you take the derivative of the outside function, which is secant, you get secant tangent. And there's always some confusion about what do you do with this x squared, and it's secant times tangent. What happens with that? Well, it's secant of x squared, tangent of x squared. That x squared shows up in both spots. And then you times by the derivative of the inside, which, yes, it shows up in 2 spots, right here and right here. That's fine. You're still going to times all of that by 2x. Okay. So that's how that works. All right, now I promise part 1 is done.